introduction to heat transfer is about heat transfer by convection and Newton's law. Okay, convection heat transfer. What is it? It's an energy transfer between a solid surface and the adjacent liquid or gas that is in motion, and it involves the combined effect of conduction and fluid motion. So there must be a conduction and fluid motion. The yang penting is fluid motion lagi besar, so the heat transfer effect by convection heat transfer is lebih besar. So if there's no bulk fluid motion, then the heat transfer is pure conduction. For example, the double glaze window. Ni kalau ada dua gelas dekat window, in between these two glass there's no gap or air in between, so this one is only by conduction, heat transfer by conduction. But if in between this gap there's air inside, so we must consider the convection effect also. Okay, there's two type of convection. One is the forced convection, and the other one is a natural convection. The forced convection is the motion, fluid motion is forced to flow over the surface by external means. Contohnya kalau ada fan, pump or the wind that make the flow of air become higher, faster. So this one we consider as forced convection. But for natural convection, fluid motion is caused by beyond forces caused by density difference due to the variation of temperature in the fluid. So tak ada flow dia tak besar. Okay, the process that involve phase change, kalau daripada gas to air, phase change, cair. Also we have to consider convection due to the fluid motion induced during the process. Contohnya the rise of vapor bubbles during boiling. Masa air mendidih dia akan jadi vapor. Itu pun ada phase change. Or the fall of liquids droplets into during condition. So from wap air, it becomes titik cecair. So because of it, the liquid droplets ada then ada liquid punya kesan effect. Then we have to consider also the convection heat transfer. Okay, the physical mechanism of convection. Conduction and convection both require the presence of material medium, ada material, but convection requires fluid motion. So kalau kat sini contohnya ada air, the air is flowing, so they consider the air is have fluid motion, the motion, and the convection involves fluid motion as well as heat conduction. So at the same time, the heat conduction from the solid surface pun ada. Okay, so this one is heat transfer from hot surface, one is forced convection, one is natural convection, and this one is only conduction. Okay, heat transfer through solid is always by conduction, kalau solid to solid, but heat transfer through a fluid by convection in the presence of bulk flow motion and by conduction in the absence of it. So kalau forced convection ni, contohnya kalau ada tadi kipas, due to this fan, the airflow is very high, and this we consider ada forced convection. But if it's natural without any fan, tapi warmer air rising at the same time, meaning to say that air is flowing, So the convection are occurred is occurred, and then due to this we call as natural convection, sebab ada pergerakan angin dalam udara tu, pergerakan udara. But if there's no convection current, kalau angin tak bergerak, then most probably it's only conduction punya effect of heat transfer. Okay, so this heat transfer from a hot surface to surrounding fluid. Okay, therefore conduction in fluid can be viewed as a limiting case of convection corresponding to the case of quiescent fluid. The fluid motion enhanced heat transfer. So lagi besar fluid, bigger heat transfer. So since it's bring warmer, cooler chunks of fluid into contact, initiating higher rates of conduction as a great number of sites in a fluid. So the rate of heat transfer through a fluid is much higher by convection than is by conduction. And in fact, the higher fluid velocity, the higher rate of heat transfer. So contohnya kalau kita ada hot plate and cold plate, and in between that we have fluid or air also considered, okay. And heat transfer to the fluid is Q dash Q dot. Heat transfer through a fluid sandwich between two parallel will be by convection. This one is convection only. Okay, how to calculate it? We use the Newton's law of cooling. Heat transfer from a solid surface with area A and temperature Ts on the surface of solid to a moving fluid temperature T infinity is given by Q is equals to H times A times the heat difference, the temperature difference. Okay, H is the convection transfer coefficient, sama juga macam conduction coefficient, and surface area normal to the direction of heat transfer, and T surface temperature of solid surface usually we will take as K Kelvin, and the temperature, average temperature of the fluid in Kelvin also. So the surface ini solid at the surface Ts temperature, and we have fluid, and the fluid's temperature is T infinity. So the flow is actually 0 at the surface, but the fluid flow will become bigger as it is further to the solid surface. Okay, what is convection heat transfer? H is not a fluid property. It is a parameter determined by experiment. It can be determined by experiment. The value depends on the variable influencing convection, such as surface geometry, nature of fluid motion, the property of fluid, and the bulk fluid velocity. Because of this, H will be affected. H may become bigger or become smaller. Okay, this is some of the typical values of H. If it's free convection and forced convection, usually the same on the same mode. This one vertical plate of with 0.3 meter high in air. But if you see between free and forced convection, H will be bigger in forced convection. Okay, so this one is free convection and gas and liquid. This is the value usually, but for forced convection the value will be bigger. And for boiling and condensation, H will be more large, more bigger than both of the forced convection and free convection. Okay, that's all.